In this section, properties of equality, our goal is to be able to solve a two-step equation and justify the steps of solving the equation using properties of equality. Let's take a look at this situation. Number one, Yahira is 5 inches taller than twice the height of her little brother Xavier. If Yahira is 65 inches tall, how tall is Xavier? To be able to solve this problem, we're going to need to set up equations and solve equations. To be able to solve equations, we're going to need to understand the properties of equality. Here are some of the properties of equality we're going to begin with. Addition property. Addition property says we can add the same number to both sides of an equation. For example, take the equation x minus 3 equals 5. If we want to solve for x, we would add 3 to both sides of the equation. That's an example of using the addition property of equality. Sometimes this property is useful for rearranging terms in an equation, such as y minus 5 equals 2x. When we want to graph a line and we want y by itself, we want the minus 5 to not be on this side. We will add 5 to both sides of the equation. In this example, our result is y equals 2x plus 5, an equation that has y and x in it, while in this example, we have x equals 8 as a final answer. Doesn't matter what the final answer is, the point is we are adding the same number to both sides of the equation. Similarly, the subtraction property of equality says we can subtract the same number from both sides of an equation. For example, if this were to say x plus 3 equals 5, and I want the x by itself, I can subtract 3 from both sides. It does not matter what my result is, the point is I'm subtracting the same number from both sides. Now, it doesn't necessarily have to be a number. We could start with something like y plus 3x equals 8, and I want the y to be by itself, so I would subtract the 3x from both sides of the equation. Again, the point is I'm subtracting the same thing from both sides of the equation. The multiplication property of equality is similar. Multiply the same number to both sides of an equation. For example, take the equation x divided by 3 equals 5. If I want to solve for x, to do that, I'm multiplying both sides of the equation by 3. This is a useful property for getting rid of denominators. The division property of equality is similar. Says I can divide the same number from both sides of an equation. For example, 3x equals 12. I want to solve for x. I want the x by itself. I can divide both sides of the equation by 3, dividing by the same number. We're going to take a look at some examples using the properties of equality, but first let's review a couple of important words. Simplify means to make simpler or easier or plainer. Often we refer to simplifying when we want to combine like terms, such as 3x plus 5x. Those are like terms. We combine those to make 8x. We simplify from two terms to one term. This is simpler. When we justify, we say the reason why something is correct. Examples. Number one, use the properties of equality to justify each step taken to solve the equation. I've listed out the steps to solve the equation already for you. Let's go through each one and see which property of equality tells us why that step is done correctly. The equation is negative 3x plus 6 equals 18. My goal when I solve an equation is get x, in this case, or any variable, by itself. Figure out what does x equal. So if I'm trying to get x by itself, the first thing I showed was subtracting the 6 from both sides, because that is the inverse of the positive 6. So when I subtract 6 from both sides, I'm using the subtraction property of equality. Now, all of these are properties of equality. The different part is the name of the property of equality. Is it subtraction or addition or one of the other two? Then I get down to this step by combining these like terms, positive 6 and negative 6. 18 minus 6 makes 12. What did I do from this step to here? I simplified. So we're going to say simplify or combine like terms. From this equation to this equation, what looks different? I needed to get rid of the negative 3 that's multiplied to the x, so I divided both sides by negative 3. I did the same thing on both sides of the equation. This time I divided. That's the division property of equality. Finally, I have the solution x equals negative 4. How did I get from this step to this step? Well, the negative 3 divided by negative 3 left just x, and the 12 divided by negative 3 makes negative 4. Here I made this simpler. I simplified. Let's solve this equation and justify each step. I'm trying to get x by itself. I want to use my order of operations. Remember those? Backwards. Parentheses, exponents, multiplication, division, addition, subtraction. We work backwards when we're solving the equation. So I have plus 5, addition and subtraction is at the end, so that goes first when we're solving. I'm going to get rid of this positive 5. It's added, so I'm going to subtract it from both sides of the equation. Here's this side of the equation. I'm going to say minus 5. Here's the other side of the equation. I'm going to say minus 5. What justifies this step? The subtraction property of equality. For my next step, I'm going to simplify and write this equation simpler. 5 minus 5 is gone. 3 halves x is left, equals 11 minus 5 makes 6. Simplify or combine like terms to get this equation. Now from 3 halves x, I want the 3 halves to not be there, so the best way to get rid of this fraction is we're going to multiply by the reciprocal on both sides. Because I'm multiplying by the same number, that's the multiplication property of equality. That leaves a simpler x by itself. 6 times 2 is 12. 12 divided by 3 is 4. So simplify for our final solution. Let's look at another example. Number 3, the difference of 9 and the quotient of a number x and 6 is 5. Solve for x. Well, notice that this is words. First, we need to change this to an algebraic equation. Remember that difference means subtract. What are we subtracting? The difference of 9 and the quotient of a number x and 6. Quotient, remember that means divide. So we're dividing x by 6. So we're subtracting 9 minus the quotient of x and 6. X divided by 6. Remember that is means equals 5. Now we can solve for x. So I want to get x by itself. When I have an equation, I like to remember that the equals divides the two sides of the equation. So anything I do on one side, I do to the other side. So I'm trying to get the x by itself. Remember, we follow the order of operations backwards, SADMAP. Remember, PEMDAS, but we're following it backwards. So first we do subtraction and addition. The 9 is subtracted with x over 6, so I'm going to say, but it's positive, so I'm going to say minus 9 minus 9, the subtraction property of equality. That gets rid of the 9's. What I have left over, negative x over 6 equals negative 4. I want the 6 that's being divided to not be with the x. So the opposite of dividing is multiply. Remember, dividing and multiply comes next. So I'm going to say times 6. But if I want the negative to go away, I can multiply by negative 6 at the same time. So times negative 6. On the left side of the equation, I have the negative 6 divided by negative 6 gone. What's left over? Just x. On the right side of the equation, negative 4 times negative 6, 24. So I've solved for x. X equals 24.